All right, so now we're looking at the compound interest formula. This is really similar to our formula that we looked at for exponential growth. And now, but this one, instead of using K, we use R, and we call it the compound interest formula, and it comes when we have continuously compounding interest. We're going to look at this formula in some more detail in our next unit, but right now, here is our formula. So B we call our balance, and it's similar to our population number. But now we've got R being our interest rate, and T is our time in years. So how long will it take for 25,000 to grow to 80,000 if we have an interest rate of 2.25 years compounded quarterly or continuously? So continuously is this formula. Any other rate, we're going to use this formula. So let's look at these two rates. So A, we're going to use this formula. Our balance is going to be equal to our investment, 1 plus our rate over our number of compounds per year, times those number of compounds times years. So our balance, we want 80,000. Our principal was 25,000. Our rate is 2.25%, so 0.0225 divided by 4, because we're compounding quarterly, for T. And now let's plug in our other formula. So we've got, for continuous, 80,000 equals 25,000 e to the 0.0225 t. Whoa, sorry. 0.225 t. And I'm going to put these into my calculator and look at the table. So we're going to want to know, if we said quarterly, we would say to the nearest quarter. If we said continuously, maybe we would want to the nearest day. So let's just look at our solving our equations with our calculator. So y equals, all right, I'm going to put in 25,000 times 1 plus 0.0225 divided by 4 raised to the 4x, and then 25,000, oops, too many zeros, times e raised to the 0.0225x. Okay, I'm going to look at the table. So I'm looking for 80,000, and I can see that after 10 years, I'm not quite there yet. In fact, I'm not close to being there. So I'm going to come into my table settings. And in my table settings, let's start at 20 years and let's count by 5 years. Okay. And now I can see that I've got for both of them, between 50 and 55 years. So, sorry, table settings. Let's start at 50 and go up by 1. Actually, I'm going to go up by 0.25 to know the nearest quarter of the year for my left one. And again, you could solve this algebraically using logs. I can see that at 52 years exactly, I've got my investment has made it up to $80,000. If I compounded continuously, I would need, let's see here, to get up to here, 51.75 years. So slightly less time if I compound continuously. And these I went to the nearest quarter because it said quarterly. Any problem that you have will tell you to what nearest unit we want to look for.